I noticed.
Good afternoon, everybody. Welcome to AHR out in sunny Las Vegas, 2026 AHR Expo. Here at the Sporlan booth, we're talking with Mr. Paul Chambers, who's been with Sporlan. How long have you been with Sporlan?
Just crossed the 5-year mark.
5 years.
Yeah.
So you're the new Jim Jensen, from what I was told.
I am the new Jim Jensen.
Okay. Well, that, like we talked about, that's really big shoes to fill.
Yeah.
Like he was a tiny guy, but still big shoes to fill.
Yes. Very small man, very big shoes.
So before I forget, Mauricio, I know you said you'd hit me and say hello to you, but hello from Las Vegas to Mauricio. So we're here to with the Sporlan booth, podcasting every so often. Just going to talk about some random stuff. Paul, I know, I do training. You guys do training. What kind of training are you guys actually doing?
The goal for my training is mostly it's less specific to an application, more about product understanding and making sure you can actually use our products in a way that is helpful to you. You're not tearing out valves that don't need to come out. You understand the function, you understand troubleshooting, stuff like that.
Okay. So give me some specifics, let's talk about, electronic expansion valves. So what certain things are you guys teaching the guys so they're not just ripping these valves out?
Yeah. So, I mean, all of these are brought actually together, and we do call it Sporlan Specialist class. We'll do a week long. We'll bring people out, and we would have a whole section where we'll talk about electronic valves. And we'll go through and how do you ohm out a motor? How do you check if it's grounded to the body or to the can you check the steps on it? Do you check it under load? And you do these things before you just pull it out. You say, oh, it's a bad valve. Maybe you have bad controller. Maybe you have bad wiring. I'm not saying that there are no bad valves in the world. We make valves, and some of them, do fail in field. But how do you make sure that you're not doing more work than you need to be, and then getting frustrated when you have a return and I say no defect found? That's the most frustrating thing to find out.
Yeah, where they didn't find anything wrong with the actual valve. So I mean, we've done this before, where a lot of the expansion valves. Remember, they're all nominally sized, right? Mm-hmm. Sporlan, the predominant electronic expansion valve that they have and use is the SER family, right? Yes. So you have the SER AA, B, C, and D, and then there's a couple other ones. I'm not going to keep going in the alphabet, but one of the ones you guys don't make is the AAA, and I've actually been trying to get you guys to make it, and I was told the reason why is because the port size is so small.
Oh, yeah.
And it would be smaller than a piece of hair. So the reason why I complain about this is because a lot of times you have bad valves, like any other valve, any other mechanical valve. If you have a valve that's basically short size, hunting, right? So any oversized valve, whether it be mechanical or whether it be electronic, if it's oversized, it will hunt. So meaning when I mean hunting, I'm talking about going from 0 degrees of superheat up to 100 and then just keep, going back and forth. It can't find its sweet spot no matter how much P&I detuning you do, how much anything you do. And one of the things I'm sure you guys go over in your class is sizing expansion valves. Is that correct?
Absolutely, yeah. So then there's a few places you can do that. We always tell, virtual engineer is a great place to do that. You can plug in your conditions, and it'll do the math for you. And we also have our literature page. You can pull up the documents, you can pull up bulletins, and do your sizing manual if you'd like that as well.
But like I said, the problem is though, a AAA, and the only reason why I know that, or I'm sorry, if you take like a Hill Phoenix OWIZ case, that particular case only has 2,900 BTUs for the whole line. Mm-hmm. So problem is if you use an SER AA, if you do 448 or 449 at 50 degrees of subcooling, basically now that valve isn't a half a ton or 3/4 ton. Now it's like a ton and 1/8, I think it is. And I'm doing it off the top of my head because I've done this calculation 60,000 times. So in that application, that valve would be almost 5 times bigger than what that valve would be. We never want to mess with the steps because it still has to be able to find its way home.
Yep.
But what we can do is we can mess with the max opening valve percentage. And so what I typically do, and tell me if I'm wrong because you're the specialist, but what I would typically do is I usually, figure out what the valve sizing is. Let's just say, example, it needs only to be, 35% open for its max opening. I might juice it a little bit. I might go 40. I might go 45 for that additional defrost or whatever. Does that sound right to you?
Sounds right so far. Yeah, great.
Okay, because usually what will happen is if not, the valve's going to sit there and just hunt. And I've had, I usually don't get involved with a lot of things until it's broken, or until we went through 10 of these valves, we went through 15 of these valves. Why are we going through the valves? Well, let me take a look. Oh, wait, because there's a difference between starting up and commissioning, right? Starting up is just we're making the food cold. Commissioning is making sure it's running smoothly and effectively. And like I said, a lot of times we'll see where that valve will go 0 to 100, 0 to 100. and it's still maintaining cold. It's not flooding back, but it's not working as optimally as what it can be.
Yeah.
So a lot of times, like what I'll do is, okay, go through, okay, this 5-door is supposed to be this many BTUs. All right, we'll do the calculation. All right, all of them are a max opening percentage of 45, you know what I mean? And just roll through that. And now instead, it'll find its sweet spot. It might go all the way up to 45%, but then won't have to go all the way down to 0. It might find its sweet spot at 25, 35% and just sit there and just roll. Yep. And then that way we don't have any, because any more overcycling, not only is it going to affect the operation of the case, potentially affect the operation with superheat going back to the compressors, but then you have, if you have 40 cases in a lineup, you have that happening. That's like turning off circuits. So what's going to do with the compressor cycling?
Oh, it's going to wreck that.
Your line's going to be ridiculously just all over the place. Yeah. So these are the reasons why you look into some of this stuff and making sure you actually know how to size it. Not just because you know how to size it to make sure, well, wait, they don't make a AAA, so what do? You adapt and you overcome. Use the tools that you have. Like I said, don't ever mess with the steps. The valve still needs to find its way home.
Yes.
But, knowing that, I can mitigate that by saying, oh, well, I'm only going to make the valve 35% of what that actual full capacity is, right?
Yeah, we do that all the time through microthermo. You can actually go through in the graphs. You can look at historical data, look at the steps and say, hey, we are swinging all over the place, but on average, we hang out at 13% open. You don't want to set to 13 because that you won't be able to pull down for defrost. Set a little bit higher, maybe set 15, 20. Mm-hmm. And then through microthermal, we even have those functions you can say, hey, on defrost, we need a little bit extra juice there. So have a modifier. We'll do an extra 10% on defrost. So if we're in defrost, let it open even more because we do need to have those quick pull downs. But never modify the steps. It needs to rehome. All of them will rehome on shutdown as well.
Okay, so what he's referring to, if you don't know what he's talking about, if no one's ever monkeyed with the microthermal, every single one has a base value, and then there's an extended value. Yep. Base value is there. What you're supposed to typically do, what I was told, is just let the valve run and let it run like crap, and then find where the graph, where it spends most of its time. So if it's going from 0 to 50, and it seems like it's spending most of its time at 25 or 35%, that's what you're going to do. And then basically is it external? What's the other value for the extended?
Oh, what is the term for that? It's not.
I'm having a brain fart right now.
Same.
But there's there's another part that the base value basically is giving you the percentage of where it's typically running, and that other value is to give you essentially the extra oomph to make sure you can still pull down during defrost.
Yeah.
One of the things I found out with playing with microthermal is I don't really like, and maybe you can explain to me why this does it. So a lot of times they'll do I think I might be able to explain it. See if I'm right. A lot of times they'll do temperature and then superheat. So the problem is with that, like temperature superheat, if it's above the temperature, it's just going to overextend past the base value, correct? Mm-hmm. And then it starts hunting real bad. So like when I like setting up microthermal, I like making it at superheat and then temperature. So it will try to maintain superheat because most cases work awesome if the superheat is cruising along there. Yeah. And then if God forbid the temperature does go down lower than what the threshold should be, at that point it would shut off, correct?
Correct. Okay. Yes. Yeah. Different people have different designer requirements that they're looking for, or different requests and just not set up. So the main thing I always help people steer clear of, the one control method I like is temperature only, and we see people do that, or superheat only. If you're doing one only, people say, well, my superheat's just dropping out of, it's like, well, you're only looking at temperature. You're not calculating off that superheat limit. And vice versa. People say, well, my temps are all too high and we have great superheat. Not controlling the temperature at all, which is the problem of having those electronic controls is people start to think they're going to behave so much differently than mechanical. All it is a electronic valve trying to repeat what the mechanical valves are doing.
Yeah, but then again, like if superheat alone, you probably have problems where at one point it ends up getting too low because there's no load on the case.
Yeah.
And you're not doing, it would probably work really well, and correct me if I'm wrong, if you would end up doing float, right? Like if you would end up doing float and have the cases running. The problem is with a lot of the cases nowadays, like over in Europe, everything has a 10-degree TD. So like if you float, then you're floating everything with a 10-degree TD. So everything's going to maintain fairly close to each other. Here in the States, we have cases that have a 4-degree TD. Now, just to elaborate, when I talk about TD, because people question me this all the time, what do you refer to as TD? I refer to it as the saturated suction versus basically the discharge air coming out of the honeycombs. Every case manufacturer will give you their TD. Husband, Tyler, Hill Phoenix, Husband, if I didn't already say it, they all have a set TD of what they actually operate as far as their cases. The reason why is because obviously the lower the TD, that means essentially the lower the compression ratio that the compressor has to be. Unfortunately, we have boxes that have 8 to 10 degree TD that, if you're trying to maintain 30, you have to pull all the way down to 20. Well, here's the problem. Now we have a case that's operating at 28 degrees that only needs to be a saturated suction of 24. So we're running way colder than really what we need to. And not every single store out there, regardless if we're talking CO2, regardless if we're talking about HFCs or HCFCs, sorry, if you lower the temperature, lower the pressure. So if everything's remaining real low, we're going to end up pulling that case down way lower than what God intended.
Yep, and that's what we see. And that's why I don't prefer that control method.
Gotcha. What else you guys doing in trading? So give me some other things. Not putting solenoids in backwards, maybe?
Not putting solenoids in backwards,
Okay.
not sizing them off of line size.
What do you mean? Why can't you do that?
I mean, you could do it if you would.
Why can't you? Why? Tell me.
Pressure drop matters.
Okay, why?
Because pressure drop is what we're going to use to close that solenoid in operation.
Okay.
It goes through and creates pressure drop in the valve, helps it close when de-energized.
Okay.
If you don't have the right pressure drop, it's oversized. You have a low pressure drop. You can open up, no problem. Go to close, it won't close back. And I had someone call me, "Hey, I can open it when I ramp the flow up. It works great, but if it went under low conditions, like, well, what's your pressure drop? Well, I didn't measure that. First thing to look at."
Well, I mean, we don't really like certain applications. We don't want a high pressure drop, right? Liquid lines definitely don't want a high pressure drop. We want at least probably a half to 1 psi, correct?
1 would be great, yeah.
Well, all right, so then don't listen to me on half. One would be great. The reason why we want to do that, like you said, because if you actually look at the cutaway, there's 2 little holes inside that disc, and basically that pressure goes up through and helps actually seat that valve down. And that essentially, usually, what happens is when you size an expansion, when you size a solenoid valve based off of just the
line size.
The line size. Thank you. Can't think today. What happens is that we can't close, and this happens on any type of valve, regardless if you use it for suction, regardless if you're using discharge. Discharge valves are a little bit different. We can have a higher pressure drop and not really be concerned. The reason why we don't want a high pressure drop with the liquid line is because we create a pressure drop, right? Then basically it'll be lower pressure on the outlet, okay? But then the temperature is set. So, I mean, we could mess with the subcooling and potentially not, force ourselves to essentially, flash off and not want to.
Yeah.
Right?
Yep.
Okay. What else are you guys going through in trading?
I mean, we're Sporlan, so we definitely go over the TEV. We go through the basic functions, the forces on the inside.
Okay.
Jansen used to have a whole other list of forces that I'm not allowed to talk about now.
Why?
I believe it was something about the girlfriend, the mother-in-law, and the wife.
All right, we're not going to talk about that. All right.
But yeah, like I said, proper understanding of what the valve is doing. So when we go through and actually look cutaways of the thermostatic expansion valve, and when does it open, why does it open? It's not magic, it is science, and if you understand it, you're going to troubleshoot it better. And then we'll go through troubleshooting is why is my superheat low, why is my temp high, stuff like that.
You guys go through the going back to expansion valves for a second since you brought it up. You guys are also going through the charges on the actual expansion valves themselves, right?
Oh yeah, that's a great opportunity. We get to go through nomenclature. So what does it mean? How do you choose a charge? How do you cross reference and stuff like that? If you're doing a retrofit, what do you have to do? What do you have to pull? So
it's amazing. Like all the guys that I've trained, technicians. I should technicians. I've trained a bunch of women out there as well. Funny thing is that they don't actually realize that the numbers on the valve, like you don't need that. Like I know the tag being there for like a liquid line solenoid is really convenient, but like every single one of those numbers and letters means something.
Yes.
So if you have an ME, M means manual opening. E is actually, I think, extended ends is what it stands for, right?
Yep.
Or an E port, and then the next number is going to be your port size. Port size, it doesn't mean that's the amount of tons. It's the port size of that actual valve. The next letter is going to be typically an S for sweat. The next number in a solenoid is going to be either a 1 or 2. And people are like, what does that mean? Well, there's only 2 types of solenoid coils that we have. We have an MKC1 and we have an MKC2. So guess what that means? The next number after that would be the actual pipe size. And it was like, well, what's a 50? Well, Sporlan, Flowcon, Parker, they all do it in eighths. So 5 would be 5/8. A 7 would be 7/8. 11 would be 1 11/8. No, it wouldn't be that. It would be an inch and 3/8.
Yep.
And that I use that analogy all the time when I'm training because like they'll be repeating, they're right on it. They're like 5/8, 7/8, and I'm like 11. They're like 11/8. I'm like no.
Yeah, I mean 11/8, but then you need a weird fraction there. So
yeah. What else are you guys going through? Like I know you guys are doing more MT training as well. Yes.
Yes, we are.
Okay. Bare bones basic, like just overview of stuff. Or are you guys doing through like advanced programming? What are you guys doing over there at Sporlan?
Yeah, so we do the basic, and then we're trying to ramp up that really in-depth training. We have that right now through the Canada office up in Mirabel, and we're aware that not everybody can get up there.
Wait, where?
Mirabel. It's
You don't know where it is in Canada.
no, I have no idea. I don't know.
Unbelievable.
I'm not a good Canadian.
I'm telling Dennis right now.
Well, Dennis isn't a good Canadian either. He's actually also from the States. So now don't tell Mark Gagne and those guys that I don't know where they're at. So.
Mark Gagne, he doesn't know where the place is up for microthermal. So just
it's true.
And Heath probably knows where it is.
Oh, Heath definitely knows where it is. And
love that man's mustache.
He's got a great mustache. Well, he's a firefighter. I think it's a law now.
Yeah, I think that is.
So but no, we know that not everyone can get up there. So we're trying to bring that training down, make sure everyone has the answers that they're looking for. If you want to use our product, we don't want you to be confused. We want to be able to help you to use it. So
understood.
Yeah.
What other, so you do have some basic microthermal training. You also do have some advanced stuff somewhere in Canada that you don't know where it is.
Yeah.
But they have it. They have it available, right?
Yeah.
Okay. What other things you guys going through as far as training? Because you hold your training where?
Washington, Missouri. It's about an hour west of St. Louis.
Okay.
Yeah. And it's a great opportunity. I mean, so we have our trainings. We'll go through S3Cs would be another thing we go through. So using the Tech Check app, going through and actually setting up and looking through the graphs, stuff like that through the S3Cs. But we also get the opportunity to show you what Sporlan does. So if you got in through one of those training classes, we'll take you through the plant. You'll actually get to see how we manufacture, how we 100% test everything that goes out of our facilities. And that's something we like to stress is that if we send a part out, we have good confidence it's going to work because we 100% test it. We've had people ask, why do rebuild kits cost so much? It's like, well, we 100% test. So if I want to test a rebuild kit, I'm going to have to put it in a valve and test that it actually seats that tech, and then pull it back out of that body and send it out. So there's a lot of stuff into getting that stuff out. And then we can even show you the lab. So that's where I've been in Sporlan for 5 years and only in this job for a couple months now. First 5 years was actually in the lab testing this stuff. So how do we develop our valves? Either design verification or systems testing. So we have our own supermarket test lab where we've got two racks and a third support rack. We have our psychrometric rooms, or psych rooms as we like to call it if we want to confuse people outside.
Yeah.
So doing all that, take people through, actually show them what we do, how to use it, how to apply it.
So I do want to say, if you are AHR this year, they are giving away the magical Sporlan adjustment tool for the expansion valve.
Yes, sir.
I have to ask you, I'm going to put you on the spot. I don't really care. Why? Why? Because everyone's very upset about this whole thing.
I've
right?
heard, yeah.
So why? Why do we go to that design? It's been the square for longer than I've been alive.
Yeah. The main thing is if you take apart that the adjustable bottom cap. The old one that had the square head there's a lot of pieces in that. I mean, we're at 7+ pieces.
Okay.
The new one that has the hex head has I think 3 or 4. So less pieces means less variation.
Less leak.
But also just every time you design something, every piece has a tolerance. Every tolerance stacks up. The more tolerance stack up, the more opportunity for error.
Okay.
So in theory, if you have less pieces on an adjusting assembly that you're going to use to set secret, you could actually have an ATS, I should say. You could actually, in theory, have a tighter ATS as well because there's less pieces to move and walk around.
All right, fair enough.
And then the last thing of why hex versus square is the less stuff that's unique to us. So if you can get something that's more easy to find, easy to procure, that also means lower lead times and less likely that you're going to be. We see the whole industry doing that, trying to get simple by design, something that you can grab anywhere, even if that supplier drops out, we can still get you the valves you need. So I'm not unaware that people are unhappy about it, but I think it's going to be a good move.
Gotcha. And then, if anyone really doesn't know, if they actually look at the Sporlan logo,
Yes.
That's actually the needle assembly for an expansion valve.
Yeah, I used that in the description yesterday. Someone was actually trying to understand the difference between a TEV, SER, and SPW. So
Yeah.
I was able to explain that.
So I have another question for you, since we were talking a little bit about nomenclature. And once again, I'm putting you on the spot, but I just don't care because I know you're going to know this.
No, we'll see.
Why is it the fact that we can actually use a C commercial charge? I mean, with 448, 449, and 22, why we can use it at such a lower temperature?
That is a hard question for me, actually. I will
What?
say, hey man, I came from research, and if it's older stuff,
You
now
should have researched it.
I should have researched. So as for why you can use one charge in a certain application, it all comes down to a charge is everything in that bulb and element is just a designed to have a certain pressure temperature relationship.
Agreed, but it's not the refrigerant that's actually in the system, because otherwise you'd reach equilibrium and it wouldn't work.
Correct.
I walked up to a job site the one day, the expansion valve wasn't feeding, and I saw someone had brazed a stinger tee on there, and I was like, "What? Why?" And so I guess they had a rub through, didn't have the power head, and they they put it back together and put that on there. No, because like every other commercial charge, right? I mean,
Yeah.
they're good. Sporlan typically for the commercial charge goes from 50 degrees down to -10. And then if you look at the very, very bottom, there's usually a little asterisk, and it'll say R22 and R22 type replacements, 448, 449, 407, maybe 422F, but no one wants to talk about that one. But what I'm getting at, so you can use the commercial charge for not only a dual temp coffin, right? So one that can do medium and low temp. Actually, even Hussman, even in all their cases, for their RL cases, they're for any kind of HFC, they're HCFC. Sorry, they're actually putting in commercial chargers. They're not even touching the Z charge, which is typically used for the low temp.
So I will say I have some room to learn, and I've been doing that these last couple of months in this new job. And we have actually that's where I started to learn. We have seen people who try to go to those lower charges because they're on the threshold, and it wasn't functioning right, wasn't flowing right. Then we brought them back to that C charge because it goes down to -10. If you're at 0, don't go to the low temp. It's a low temp, so I'll use this low temp charge. No, use the one that actually has the range. It's all about the pressure temperature relationship. And if it's in our defined, hey, we say operates in this range, it's good to go no matter what.
So besides those valves, so even in your Sporlan training, are you guys also going over sizing sport valves?
A little bit.
Okay.
So that's probably an opportunity we have to grow. One of the rooms I have a lot to learn is our refrigerations, the large refrigerants, RS side.
Okay.
I didn't do a whole lot of that in the lab, so we're bringing that a little bit in.
Same thing, right?
Yeah.
You have, if it's used for a liquid, then it's there's going to be a liquid adjusting factor.
Yeah.
Pressure is going to give you an adjusted factor. Suction line temperature, how much superheat you have.
Yep.
So that's going to dictate how much mass flow you have. Blah blah blah. And yeah. So
we get into nomenclature a little bit, and I definitely lean on the product managers. We have a lot of guys in Sporlan who have a lot of experience. I get to bring them in. If you came for one of those trainings, you wouldn't listen to me talk for days. That would be horrible, and you wouldn't learn enough. So I bring in a lot of other knowledge and a lot of other help to teach these classes.
do you have any hands-on stuff at all?
We do, yeah. So
really? Okay.
Yeah.
What are you guys doing?
Really basic stuff. A lot of guys. It depends on who's coming in. So a lot of these guys have never actually built a Q valve.
Oh, you can't just tighten that down with a huge ass socket wrench?
You could if you don't want it to open ever again.
Oh, cool. All right, we can do that.
So we go through that, build that. We could do tear down on an EPR, something like that. Show a CDS conversion, and it depends on the classes. So for a lot of these guys who come in, some of them are technicians, some of these are counter guys, and they want to know, hey, I got these technicians coming in. They're asking me questions, and I don't know the answers.
So one of the things I would totally recommend, a lot of times, and I'm not dogging any supply house cats, but sometimes you tell them you need this valve, and they don't do any sizing whatsoever. Where let's just say you go in with this, where I don't know, if I was a counter guy, I'd be like, all right, what's your saturated suction? What are you running? What's your liquid temperature? What's your delta P? Your delta P is basically the difference between your liquid and the suction. Because if anyone doesn't know, the delta P is actually going to affect the size of the expansion valve. The bigger the delta P, the bigger the valve. Smaller the delta P, smaller the valve. So just keep that in mind.
Yeah. So just once again, we want to equip everybody to do this right. And there's the joke about you going to buy fuel tubing from O'Reilly's and what's make model and we want to make sure that you always want to ask the right questions. So if I don't know, I'm a technician, I don't know, and I come in, hey, I need a 3/8 E series solenoid.
Well, they rely on the supply house a lot, and a lot of the supply houses now have do you have the part number?
Exactly.
They don't actually know like why the application. Like I remember going to one guy up in United. God, he's not with us anymore. Scott is up in United Hartford, and that guy, man, like you could tell him like all the specs. He's like, oh yeah, it's supposed to be an 89497, but I don't have that. But I can give you a 4574 and it'll get you out of the woodwork for the time being.
Yeah, and so we want to get more guys like that in the field. So teaching this stuff, teaching the how and the why, and then the nomenclature as well. So
cool.
Yeah.
Well, hey, listen, Paul.
Yeah,
it was great talking to you.
Yeah, my pleasure.
And hey, listen, we're going to be here at AHR over at the Sporlan booth the rest of the afternoon. So if you guys are around, please come on, get yourself a foam filter dryer that you can throw at people, and also get yourself the little coins for the adjustment stem on the new expansion valves. We'll guys talk to you there. Have a good one. Bye.